Hi everyone! Today we will be looking at the effects of our parameter a. Here's today's learning target. Given a quadratic function in vertex form, I will be able to describe the effects of a. What are the effects of our parameter a? Here is our function written in vertex form. F of x equals a times x minus h quantity squared plus k. Today we are focusing on the parameter a. What does a do to our function? In other words, we are going to ignore h and k today. So today's general form will look like this. F of x equals a times x squared. H and k told us about the function's translations, but what is a going to tell us? So what are the effects of a? Let's take a look. We are going to make some observations. Our first observation is that when a equals 1, we actually have the parent function. Why is that? It's because if we have a times x squared and replace the a with 1, we have 1 times x squared, which is just x squared, our parent function. Let's see what happens when a becomes larger than 1. So what happens when a becomes bigger and bigger? Notice how the graph gets more narrow. The graph has a vertical stretch. It becomes more narrow as a gets larger. So when a is greater than 1, we have a vertical stretch. The graph becomes narrower. It would look something like this, where the graph is more narrow compared to the parent function. And then what happens as a becomes smaller than 1? What is happening to the graph? The graph is getting wider as a becomes smaller than 1. This is called a vertical shrink. So when a is less than 1, so something like 0.4 or 0.7, there is a vertical shrink. The graph becomes wider. So notice here, the graph is wider compared to our parent function. So what are the effects of a? A gives us our dilation or scale. So it tells us whether the graph will be more narrow or more wide. So it tells us whether our graph will be stretched out, so narrower, or if our graph has a vertical shrink, so wider. Let's look at our first example. Describe the transformation of the function f of x equals 4 times x squared. First, as usual, we want to label our parameter. So what is our a value? The general form is f of x equals a times x squared. And we have an exact match where a is replaced by 4. So a equals 4, and is 4 bigger than or smaller than 1? Well, 4 is greater than 1, so we'll have a vertical stretch. So let's provide a description. We have a parabola that has a vertical stretch. So this is our description of the function, a parabola that has a vertical stretch. And a vertical stretch means the graph is narrower compared to the parent function. Like we see here on Desmos, the graph is more narrow compared to the original parent function. For our second example, let's describe the transformation of the function f of x equals 0.3 times x squared. Our general form for today is f of x equals a times x squared. And a here is replaced by 0.3. So a equals 0.3, and 0.3 is less than 1, so we'll have a vertical shrink. So let's provide our description of the transformation. A parabola that has a vertical shrink. So we have a parabola that has a vertical shrink, which means this graph is wider compared to the parent function, as we see here on Desmos. Again, the graph is wider than that of the parent function. Please try this example on Edpuzzle. Describe the transformation of the function f of x equals 7 times x squared. Is your a value greater than 1, or is it less than 1? I have another question about a. What happens if a is negative? What happens to our graph? So on Desmos, let's take a look at what happens as a becomes negative. Notice how the parabola flipped over. There was a reflection. So aside from dilations, A tells us one more thing. When a is negative, there is a reflection. So when a is negative, the parabola flips around. With that in mind, let's look at example 4. Describe the transformation of the function f of x equals negative 2 times x squared. I'm going to write f of x equals a times x squared, and I see that a is replaced by negative 2. A equals negative 2. Since it's negative, there must be a reflection. And we just focus on the number 2. Since that is greater than 1, we'll have a vertical stretch as well. So we have a parabola that has a reflection and it also has a vertical stretch, so it also becomes narrower. So we have a parabola that has a reflection and a vertical stretch. What does the graph look like? So here, notice that the parabola is reflected and it's also a little bit narrower compared to the original parent function. For example 5, describe the transformation of the function f of x equals negative 0.5 times x squared. F of x equals a times x squared, and for this example, a is replaced by negative 0.5. So a equals negative 0.5. Since a is negative, there will be a reflection. And just focusing on the number, so 0.5, well, 0.5 is less than 1, so we'll have a vertical shrink as well. So there's a parabola that has a reflection because a is negative and a vertical shrink because a is less than 1. So we have a parabola that has a reflection and a vertical shrink. Looking at the actual graph, I noticed that from the parent function, we would reflect it and then have a vertical shrink, so make it a little bit wider. Please try this example on your own. Describe the transformation of the function f of x equals negative 0.8 times x squared. Notice there's a negative. Just as a review, the vertex form of a quadratic function is f of x equals a times x minus h quantity squared plus k. And today we focused on A. A gives you the dilation. So if A is greater than 1, there is a vertical stretch. It becomes more narrow. And if A is less than 1, there is a vertical shrink. The graph becomes wider. Also, if A is negative, there is a reflection. Your parabola is flipped around. Great job today, and please remember to submit your notes on Canvas.